So this one is actually quite straightforward. So a university, so let's go through together. So a university has a large number of courses in its catalog, attribute of course. So basically we want to, I kind of give a hint, right? So we want to store information about course, and attributes are course name, course number, name, and units like this. And each course have one or more different courses prefix, and there are more business rules there. So first of all, we have to draw course as an entity, and attributes are course number and the course name and the units. So here, primary key can be course number because it's the unique number assigned to every course. So course number is primary key. And okay, let's look at the business rule. Each course may have one or more different courses as a prerequisite, or may have no prerequisite. So prerequisite is a required course. So if you want to take this course, you have to take another course, something like that. So similarly, a particular course may be a prerequisite for any number of courses, or may not be prerequisite for any other courses. So basically, it's a relationship of a prerequisite. So one course can be prerequisite of another course, like this. So let's look at the first business rule here. So from the one course's perspective. So if there is a course, this course may require several prerequisites. It says that course may have one or more prerequisites, so maximum many basically, or may have no prerequisite, so minimum 0. So it may not have any prerequisite and maximum many prerequisite. So let's just think from here now. So what if my course is a prerequisite? So how many other courses can use this course as a prerequisite? Then it says that particular course may be prerequisite for any number of courses or may not be a prerequisite. So minimum 0, basically, and maximum many. So that's it. So basically, this is the answer for exercise 1. So it's since the maximum cardinality of both sides of a relationship is many, we call this as unary unary many to many relationship. So that will be the ER diagram answer from exercise 1. So this one, basically it's this. College course may have one or more scheduled section. So basically we want to represent the relationship between the course and section, right? So here, attributes of a course include distinct course ID, course name, units. Attributes of a section include section number, semester ID, and yeah, like this. Okay, so first of all, we can define course entity here and the section entity here. So course entity will have a course ID as a primary key and course name and units. For a section, we have a section number and semester ID. And we have this relationship offer. So course offers section like this. Let me see. Yeah, so college course may have one or more scheduled section or may not have any scheduled section, right? So if it doesn't have any section, 0. If it offers one or many, so it's a maximum many. And each section should belong to one course, right? So yeah, let me see this actually. I see. Yeah, I'll show you this later. This is actually important. Yeah. So the question is this: what is the primary key of the section, right? So here the thing is this: So you have to think about a little bit. So it says that section number. Okay, change this into pen. Okay, so it says that section number distinguishes one section from another for the same course, but does not distinguish identify a specific class. So what it means is this. So if you think about this, our class as an example, then basically we have a course ID DSME6751, right? So this is the course ID, and there is a section number. So section number of this course is IA, right? And then we have a semester ID here. Semester ID is 2020 T2, something like that. Okay, so we have this. So if we make a section number as a primary key, there's a problem because another course, DSME, let's say 6650, they may also have IA section, right? Which is offered in the same semester, 2020 T2. So if we use the section number as a primary key alone, it's not a good design because we are not able to distinguish this section, this class from this class, right? These are different class, but we are not able to distinguish these two because section number is the same. So we cannot use simply this as a primary key. So what if we use the section number and semester ID together as a primary key? Still the same, right? Section number is the same, semester ID is the same. So we are still not able to distinguish these two from each other. So what should we do? Like, what should we do to make it possible to distinguish this one class from another class? Then we have to add a new field for the primary key here. So in this case, every section belongs to one course, right? So for every section, we have a course ID. So we can simply bring course ID here and make it as primary key together. Then if we use CID, section number, semester ID, all three as a primary key, then we are able to distinguish one specific class from another. So in this case, that was the main thing. So for section entity, because section number itself and semester ID together doesn't work to distinguish one specific class from another, we have to bring course ID here and use that also as a primary key. So basically, we are using course ID, section number, semester ID, or three as primary key. Then we are able to distinguish one class from others. So that was the main question here. Okay, so let me go through it together. So, okay, company has a number of employee, the attribute of employee. So basically, we want to make this identity. Attribute of employee includes employee ID, name, address, and birth date. And also a company has several projects. So attribute of project include the project ID, project name, start date. So each employee may be assigned to any number of projects, including to none. A project must have at least one employee like this. Okay, so let me first put employee and project here. So there's an employee entity and project entity. So employee, we have a employee ID, name, address, and date of birth, which is date of birth here. And the employee ID can be the primary key in this case. For project, we have a project ID, which can be primary key, and project name, and start date, like this. Okay, so that can be entity, and each employee is assigned to project. So basically, it's about the relationship assigned to. So we make this relationship, and each employee is assigned to project, like this. So let's just think about the cardinality from the employee's perspective first. So each employee may be assigned to any number of projects, including to none. So employee may not be assigned to anyone, and maximum any number of projects. So that's the cardinality here. And from the project perspective, project must have at least one employee assigned. So at least one. So minimum one employee should be there and may have any number of employees. So may have any number of employees. So it's many-to-many relationship. Okay, so an employee's billing rate may vary by project and the company wish to record the applicable billing rate for each employee when assigned to a particular project. So what this means is this. So there's employee 1, employee 2, and there's a project 1. There's a project 1, project 2. So employee 1, employee 2, like this. So employee 1 may be assigned to project 1 and project 2. And employee 2 may be assigned to project 2 only, like this. So let's say that that was the assignment. Then when they are assigned, their billing rate will be determined. So employee 1 assigned to project 1, right? So here, his billing rate may be 30%. So 30% of, he will gain like 30% as a billing rate from the project. And employee 2 is not assigned to project 1, so there's 0. So for project 1, employee 1 is 30%, but employee 2, there's nothing. For project 2, employee 1 and employee 2 is assigned. So employee 1, when he was assigned, his billing rate was 10%, and employee 2 maybe was 15%, something like this. So basically, this information is billing rate, and we want to store this billing rate somewhere in our ER diagram. And we cannot put this billing rate information in the employee entity. We cannot do that because it doesn't depend on only employee. So even though it's the same employee, the billing rate is different depending on the project. So we cannot save it here. We cannot save it in the project entity too. We cannot do that because each project have multiple employee like this. And for each, even though it's the same project, depending on the employee, the billing rate is different. So we cannot save it here. So here's the thing I want to mention. So I didn't talk about this earlier, but this is a many-to-many relationship, right? So many-to-many relationship basically does an assignment. So it has information about which employee is assigned to which project. So basically, when a certain employee is assigned to a certain project, the billing rate is determined. So we actually are able to store billing rate in this relationship here. So this is only possible. So I'm going to talk actually more about this next week when we talk about the relational model and database design, database implementation. But when you have many-to-many relationship like this, the many-to-many relationship will be represented as a table when you implement the database system. It's only for many-to-many relationship. If you have one-to-many, one-to-one, it doesn't work. But for many-to-many relationship, because this relationship will contain the information of the assignment, this relationship will become a table when you implement it. So for many-to-many relationship, you are actually able to put additional attribute. So in this case, the billing rate attribute can be actually added into this many-to-many relationship here. So when a certain employee is assigned to a certain project, the billing rate is determined. So that is actually the answer for exercise 3 here. Okay, so that's it. And let's look at the exercise 4. So exercise 4, we have this graded report, and we want to design, we want to provide the ER diagram which is able to manage and store all this information shown here. When we look at this graded report, there are multiple information, multiple data. We need to keep it in our database system. The first information is this right here. In the middle, there are student information. So basically, we need some place to store student information. And here there are course information, right? So we need a course entity to store this information. And also instructor information is here. So this is something we can also make it as an entity. And the last one is the semester information, right? So this is a graded report from the semester 2010-4, but the question is saying that, let me see. yeah, here, the grade report for past semester as well. So there are multiple semesters basically. So we can also make this as an entity. So basically we can create 1, 2, 3, 4 entity: student, course, semester, and instructor. So this one, okay. So we can do like this. So first of all, there's a student entity created here. And we can also have the semester entity here and the course entity here and the instructor. So we can also have an instructor entity here. So for student, we have a student ID as primary key and the name, major, address, like this. And for the course, we have the course ID as primary key and the title of the course and the what was there? Yeah, like that. Okay. And for the instructor, we have an instructor name, but we can also have a staff ID, which is not shown in the grade report, but they will have a staff ID as a primary key. And for the semester, we have a semester, what should I say, semester code. So we have a semester code as a primary key like this. So first of all, it's the student taking a course in a certain semester. So we can have this tonal relationship takes. So for the cardinality here, we can think from the perspective of a student. Let's imagine a student in a certain semester, how many courses he can take. It's possible maybe this student like had a break or is doing an internship or something like that. So he may not take any course in this semester. And if he takes, he may take many courses. So minimum 0, maximum many. So here, let's think from the course perspective, course offered in a certain semester. So course is offered in a certain semester. How many students can take it? If course is offered, there should be at least one student taking it, right? And maximum many. There are more than one student may take it. So one too many. That's the cardinality here. And for here semester, we can think from the perspective of a student in a certain taking a certain course. So student is taking a certain course. How many times he can take it? So it depends on the university rule. So it's not written on the this exercise here, but let's say that if the university does not allow a student taking the same course over and over, then he can take only one, right? So if the student is taking a certain course, he can take once and maximum once, one and only once. If the university allows a student to take the same course again, then the student may have a bad grade and he may want to change the grade into a higher one, and he may take it again. Then at least one and maximum many. That can be another option. So either one is fine in this case. And for the grade information, basically it depends on three things, right? Student taking a course in a certain semester, as a result, the student will have a grade. So earlier, in the previous exercise, I mentioned that when you have many-to-many relationship, you are able to add an attribute into that many-to-many relationship. So in this case, it's a ternary relationship, but if you look at it, here is one, here is many, here is many. So basically, when you have a ternary relationship, if you have at least two many maximum cardinality, then you can consider that as a many-to-many relationship. So in this case, here is maximum cardinality. Maximum cardinality here is many. Maximum cardinality here is many. So there are two many cardinality as a n max. So we are able to add attribute here. So we can add grade information here. So when a student taking a certain course in a certain semester, his grade will be determined like this. And another relationship we can represent is a teach. So course is taught by an instructor in a certain semester. So in the exercise, it mentions that, so if you think of here, the course taught in offered in certain semester, how many instructor can teach that course? The earlier exam, exercise said that only one instructor can teach. So one and only one. So here is the perspective of the instructor in a certain semester, how many he can teach. He may not teach any course if he's focusing on research in that semester, but he may teach many courses. So here is the perspective from instructor teaching a certain course. How many times you teach that course? So if the instructor is teaching a certain course, he may teach in one semester or many semesters. If he teach the same course over and over again. So basically, this will be the sample answer for the. Let me read it through and let me give you some time to think about it, and then I'll show you answer again. So there are five information we want to store. So we want to record the teaching score information. So basically, as you see here, there's a professor entity, semester entity, course entity. So professor teaches a certain course in a certain semester. As a student, if you take a certain course, you will get a grade later. And as a professor, if I teach a certain course, I will get a teaching score from you. So there will be teaching score information. So we want to record that. So we want to record, first of all, the score information of each course taught by each professor in a given semester. So score depends on each professor in a given semester of each course, right? It depends on the three things. And the second one is average score. So we also want to store average score information of each professor in a given semester. So in each semester, the professor may teach multiple courses, and we want to make an average, and we want to store it somewhere. Third information is average score by each professor. So each professor have taught multiple courses across multiple years. We want to make an average, and we want to store it for each professor. And the number 4 here is this average score across all the courses taught by all the professor in a given semester. Basically, it's a semester average. Each semester, there are multiple courses. We want to make an average, and we want to know what is the average in each semester. Number 5 is average score of each professor in a given year. So for each professor in a given year, we want to know what is the average score. So the first one, the score, can be actually stored here, right? So it's each course taught by each professor in a given semester. We already have that relationship here, right? Teach, which is about professor teaching a course in a certain semester. As a result, he will get a score. So the first one we can store here. And the second one, average score of each professor in a given semester. So currently, we don't have that relationship here, right? So we can create that here, which connect the professor and semester. And so in each semester, there are multiple professors, including one, and each professor can teach. It could be 0 or many or 1 or many. It doesn't matter in this case. So if he didn't teach yet, then I would say 0 and many. So it's many-to-many relationship. So for each professor in each semester, we have this average score, number 2 here. And number 3 is the average score by each professor. So that's simple, right? So each professor will have a certain score. Then we can have it here. And the next one is the average score in a given semester. So we want to calculate the average of each semester. So each semester we'll have that average. So basically we can put it here. It only depends on the semester. And number 5, average score of each professor in a given year. So in this case, we don't have a time entity year, so we can create year time entity with the year primary key and connect this with the professor entity. So each year there are multiple professors, including one. Each professor can work in at least 1 year and many years. So here we can store number 5 because this relationship is talking about a professor in a certain year. We have the average of that professor in that year. So that's it. So this is the answer for this exercise 5 basically.